think that means that's on. All right, so this might be a new subject for many of you, but what we are going to be looking at for the following 12 weeks, basically in essence, is how the central nervous system controls how we perform such a variety of skills. Right? And you might think that that's not unusual or not interesting, but if you think about it, right, the way we control this vast multitude of different skills from the moment you wake up in the morning to the moment you go to sleep, and how all that motor skill performance changes with things like age, disease, over time is absolutely fascinating. And everyone says this, but I truly feel that motor control and motor learning is the basis of many of the other sciences you'll be looking at in sports science. So hopefully you'll get something out of this. We'll gradually ease into it by looking at motor control first, the function of the central nervous system in the second week, and then we'll gradually ease into more practical applications, right? So you'll see your first 4 labs are mainly group work, there's a bit of theory to get through, etc. But then we go straight into the practice. We'll do experiments every single week that test certain concepts of motor control and motor learning eventually. All right. So what are we going to do today? Well, we're going to try and understand how motor skills can be classified based on how difficult they are for the human body. Right? Because there's a vast multitude of movements that we control. Some of them appear and reappear throughout life. There must be some classification that we can use to say, well, this motor skill is more difficult than this one, etc. We're going to also try and use or recognize some of the advantages and disadvantages of that method. And then finally, we're going to quickly touch on how can we measure motor performance, or how is motor performance measured by people like myself or other people who research in this area. So, why would we study motor control? Well, apart from what I told you right now, the interesting thing is that when you look at motor control, if you look at one single skill, right, kicking a ball, you can compare how that skill is performed by an infant and by an expert, and there are vast differences in how these people control their limbs to execute this movement. And that in itself is interesting, right? Not just because you can compare novices and elite performers, but also all of a sudden we understand why old people are not very good at kicking a ball, right? Why they're not very good at balancing on one leg, etc. So it's really important to understand motor control because it tells us something about how people acquire, reacquire, and forget motor skills over their lifetime. But what are motor skills? Well, we've got 4 characteristics of a motor skill. A motor skill has to have limb or head movement. Right? It has to be voluntary, and it has to have a particular purpose or goal. Right? We'll try and use some of these examples. In the top left, is that considered a motor skill? Top left? Yeah? All right. How about in the middle, solving the equation? Not a motor skill because? Nondescript answer. I would say that means no head or limb movement, right? There is a specific action or purpose, yeah, but it's not voluntary. Or it is voluntary, sorry, but there's no head or limb movement. How about Ochoa? Plays in Belgium now, by the way. I'm Belgian, so that's why I try to use as many Belgian examples as possible. Mexican goalkeeper, well known for his reflexes. A reflex like that, saving a ball off the line, is that a motor skill? Yes? All right. Does it have limb movement? Yes. Does it have head movement or limb movement? Yes. All right. Is it voluntary? What is the difference between a reflex and a controlled skill? When I want to perform a skill that is pre-planned, where does that planning start? What do you think? Up here, right? It starts in the brain. What about a reflex? Why is a reflex so quick? Where does the reflex, well, originate neurologically then? In the muscle? It's a part of the central nervous system, right? So, voluntary movement is controlled by the brain. Reflexes are controlled by the spinal cord. It's a really quick movement, up and down, and that's it. When the doctor hits your kneecap and your leg extends, that's not voluntarily controlled by you, it is a reflex. That's why we are not going to be talking about reflexes because they are not voluntarily controlled. And we see that same reflex down there. Walking in a crowded space, obviously a motor skill, and then I don't know why I have Matthew Perry smiling there. I must have been in a pretty good mood, or must have done it late on a Friday evening. We will use the same terminology for action that we will for skill. So in our case, it means the same thing. Right? A skill or an action has a specific purpose or a specific goal, has had a limb movement, is purposeful, and it can be learned or relearned. Right? So when we use skill or we use action, and both of these words basically for us, they mean the same thing. However, what is different is when we use the word movement. Every single skill constitutes of multiple movements. And a movement, in fact, is the characteristics that we can use to describe how the head moves or how the limbs move during a motor skill. Right? And motor skills are made up of movements. And a good way to compare that is, if we have a motor skill of walking, that walking requires different movements, whether you do it in the Sahara or you do it on grass. Right? The same motor skill requires different movements. The same thing for when we play golf. Depending on where we're hitting the ball from, we require different movements to perform the same motor skill. You'll see this throughout the next 2 years for you, because motor control and learning used to be in third year, now in second year. But for the next 2 years, you'll see this model reappearing in some way. Okay? What we are arguing is that motor skill or motor control is so complex because it's constantly influenced by the person, the performance environment, and the skill. Okay? If tomorrow, me and someone in this audience run on these stairs and we biomechanically analyze it, and the goal is to run as quickly as possible, you would see vast differences in the movements that we use to execute the same motor skill. It's influenced by the person. It's also influenced by the performance environment. If one person runs on grass and one person runs on ice, you're seeing different movements emerge within that motor skill. And obviously the skill is important as well. You're trying to run as fast as possible, you're trying to run at 80%, you're going to be using different movements. Now, that might seem quite straightforward, but it's a really interesting case, because if our central nervous system can control such a variety of movements, and within those movements it can also control influences of the person, the performance environment, and the skill, our central nervous system must have some massive capacity. It must have some extraordinary capability in order to control movement. Now, the very first step in every single motor control course is to try and understand how much demands, or what the demands are that a motor skill places on that central nervous system. Right? If a motor skill is fairly easy, we say that the demands on the central nervous system are quite limited. When a motor skill is really, really difficult, we say that the demands are huge. Right? Now, what I'd like you to do is just for a few minutes, look at these 6 motor skills, and in your head, or you can talk to your neighbors, right? Try to classify them from easy to difficult, just based on your own opinion. All right, so I'll give you a minute for that. All right, just one person, just say a number. What is the easiest out of all these motor skills? 6? Who agrees with 6? All right, yeah, fairly large group. What is the most difficult one there? 3, playing a piano concert. Who agrees with 3? a whole lot less people, right? The thing here is, if we try to analyze these motor skills based on the demands that they place on the motor control system, on the central nervous system, then that is extremely difficult to do because we have no guidelines for it, right? Of course, we can kind of understand that just standing up from a chair has reasonably limited involvement of muscles, therefore potentially the central nervous system involvement must be limited, etc. But it is quite difficult to classify these skills if you have no guidelines. So what we're going to do today, and what you do in every single first lecture that you get on motor control anywhere, is we're going to try and find better methods to classify these skills. Because being able to classify these skills from easy to difficult will also help us with clients, patients, etc., in order to understand as they evolve, as they learn, as they become better performers, are they able to do more demanding or perform more demanding skills? The very first method that's usually used is called a unidimensional system, right? So what unidimensional system means is that skills can be classified on a single line. You can see 3 lines here. That unidimensional system can classify a skill based on the size of the primary musculature that's used. A skill can either be relatively gross, that means use gross musculature, use quite a lot of musculature or large musculature, or it can be more fine, use finer musculature. Right? Examples of gross motor skills: walking, hopping, jumping. Fine motor skills: signing a check, knitting a sweater, etc. Right? The interesting thing here is that a skill can be classified anywhere along that line. That means we hardly ever find skills that are only require gross musculature or only require fine musculature. Even something like signing a check, right, still requires you to sit upright. Sitting upright still requires you to stabilize your torso. Stabilizing your torso still requires some sort of tonic activity of larger musculature. So nothing is usually nothing is on either end of the extreme, but it usually sits somewhere in between, more to one end or the other. The same thing is with the specificity of where it actually begins and ends. You'll see, I don't know why it is, must have something to do with my nerves, but I can't stand still. I'm constantly walking, and when I'm walking, I'm performing what's called a continuous motor skill. No one knows where I started, and no one knows where I ended. It's a continuous movement that goes on and on and on. The same thing if you row or if you ride a bicycle, etc. On the other end of the continuum, we've got discrete motor skills. Discrete motor skills have a clear beginning and a clear ending. If I press a button, it has a clear beginning and a clear ending. It's a discrete motor skill. Now, in the middle, we've also got a classification, and it's called a serial motor skill. And a serial motor skill is a series of discrete motor skills coupled together. Yeah? If you're running up to throw a javelin, right? The run up, the actual throw, the release, they might all be discrete skills, but they're coupled together to be a serial skill. Most of the skills related to sport would be serial motor skills. Right? And then finally, we've got the stability of the environmental context. A skill can either be open or a skill can be closed. Open means that there is outside environment that influences how we are going to control the skill. If I'm walking, and I'm walking through a really busy and crowded street, right, I've got to look at what other people are doing and adjust my own walking. That's an open skill. A closed skill would be if I'm walking around Hyde Park, no one's outside, right? It's a closed motor skill. You don't have to adapt your motor skill to environmental circumstances. Yeah? So we can classify every single motor skill that we perform somewhere along this line. However, what is the most difficult, a fine or a gross motor skill? Fine? Who says gross? No one wants to contradict. Right? What's most difficult, a continuous motor skill or a discrete motor skill? See where I'm going? This classification is interesting, right? It tells us something more, or it gives us some more in-depth information about what a skill is, you know, the kinds of demands that it places or might place on the motor control system, but actually doesn't tell us anything about whether a skill is relatively easy or relatively difficult. So this is this one-dimensional classification. As I mentioned, you can be anywhere along this continuum, right? And you can use that to describe a motor skill. But it doesn't really help us to tell us which skills place the largest demands on the motor control system. So, after that one-dimensional system was developed, of course, this is how it goes. Someone always comes up with a better idea. And of course, after the one-dimensional system, someone said, oh wait, we'll go for a two-dimensional system. And a two-dimensional system, right, rather than having everything exist on one line, we know that if something is 2 dimensions, it exists within a matrix, right? So what this person said was, well, if motor skills exist within a matrix, then the rows within that matrix might relate to one dimension, and the columns in that matrix relate to another dimension. These 2 dimensions in that classification system are environmental context and an action function. So then we get a total of 16 subcategories, right? You can see the table in front of you, rows and columns, 4, 4, 16. Right? And this is what that table looks like. And that table, you'll get a question, at least 1 or maybe 2 on your exam around this table. Don't learn the table by heart, right? You'll get to know me over the next years, or, well, years. If there's something that needs to be learned by heart, right? We're all modern, right? Is there anyone who hasn't heard of Google? No? All right, so we're all good, so you know how to look up this table. Everyone has it, every single book, it's available online, blah, blah, blah. So you don't need to know this by heart. If I want you to say something about it in the exam, I'll give you the actual table printed out. Okay? So you can see here, in this table, we've got environmental context as the rows, and action function as the columns. And what that means is we can classify every single skill that we do in one of these 16, what do you call that, one of those things, cells? Yeah, in one of these 16 cells. Right? In action function, there are 2 subdivisions. There's either body stability or body transport. Body stability means I'm not moving from point A to B. Body transport means that I'm moving in a horizontal sense from point A to B. You'll understand later why one is more demanding than the other. The second part is, and I made a mistake here, this should be object manipulation. Can you see that? Yeah. So it's either, are you manipulating an object or are you not manipulating an object? Then finally we go to environmental context, and environmental context is everything around us that might influence how we perform a skill. There is the regulatory conditions. What that means is everything in the environment around us that directly influences how we are going to control a skill. And then finally, there's inter-trial variability or no inter-trial variability. Inter-trial variability means every time I perform the skill, it is exactly the same. The demands it places on me are exactly the same. Inter-trial variability is that every time I perform it, the demands are different. I'll use some examples and things will become all clear. Why I do this, I don't know. Yeah, so first, let's look at the environmental context. The regulatory conditions, the things in the environment that affect how we are going to perform a skill, can be stationary or in motion. Stationary, when there is nothing in the environment that influences how you perform that skill. Nothing in the environment that's going to make you alter your movements. However, when regulatory conditions are in motion, then there are environmental influences. Right? These environmental influences can be things like other people, they can be instabilities in surfaces, etc. Intertrial variability or no intertrial variability. No intertrial variability, if I go swimming in a pool, the same pool, under the same circumstances, the same temperature, every single time, then there are no influences in the environment that influence me different every time I perform that motor skill. There's no intertrial variability. The demands it places on my body are exactly the same every single time from a motor skill perspective. Intertrial variability is if you kayak or even swim in open water, every single time you go out to perform that skill, it is going to be different. The demands that are placed on your body are going to be different. And that's intertrial variability. In the column section, right, we can have body stability. Body stability, remember, means I'm not moving from point A to B. Someone might be walking, right, but they are not moving from point A to B. Body transport is when a person is moving in a horizontal plane from point A to B. Yeah? Jumping up vertically is not body transport. The reason why that is I'll quickly tell you, you can look it up at home if you're interested, is motor skill performance becomes increasingly more complicated when you're moving through an environment. Because when you're moving through an environment, you get what's called perceptual flow. And you constantly have to adapt to things that are coming towards you. Right? So if you're moving from point A to B, we say that a motor skill is more demanding than when you're stationary. And finally, you can have object manipulation or no object manipulation. Right? If someone is just standing still, or even when they are using an object, but the object doesn't influence how they're performing the motor skill, you have no object manipulation, and object manipulation obviously makes sense. Right? So what I'd like you to do is to have a quick 1 minute, again, let's say this part of the lecture room, right? This side, I want you to think of something that would fit into the category 2B. This middle part, think of something that fits into category 1D, and then this right part, think of something that fits into category 4C. 1 minute. All right, good. Someone from this side, what did you have for C? Right? Yellow something. Could be wrong. Swimming in open water. All right, let's analyze it. Swimming in open water means, let's start with the columns. Is there body transport or body stability? Body transport. Object manipulation or no object manipulation? No object manipulation. All right. Are the regulatory conditions, the things that are on the outside, right, in the environment that influence which movements we have to use to perform a motor skill, are they in motion or stationary? Open water swimming, in motion, I would say, right? Sometimes there's current pushing, you have to swim a bit faster. Sometimes, you know, shark might be chasing you. That's maybe an unrealistic example, but anyway, we understand that. And then, is there intertrial variability or no intertrial variability? Intertrial variability, excellent, well done. All right, let's move to this group. You've got 2B. Oh, sorry, 2B. Sorry, we'll start 2B first. I could have stood there a long time. Throwing darts. All right, let's analyze it. Throwing darts. So we've got body stability, very good. Object manipulation, so we're in the B column already. The regulatory conditions are stationary. If you're doing it by yourself, not against an opponent, and you're only throwing the first dart, so you don't have to adapt based on the previous two, etc. Yes, I would say regulatory conditions are stationary. Intertrial variability, why would you argue there's intertrial variability? And not just you, I'm looking at you because you said something that anyone can answer. Very good. So if you say, well, sometimes I'm going for the bullseye, sometimes I'm going triple 20, and sometimes I just have a bet, who gets closest to a certain area, right? Then that's fine. See what I'm saying here is that if I give you a question on the exam, right? The worst thing you can do is not argue your response, because sometimes you've got something in your head, right? A certain motor skill, and maybe I haven't defined it specifically, which I usually do on purpose, right? Because it weeds out the students who are just lazy and write down something versus those who actually think about it. Argue, yeah? That's perfectly fine. And if your argument is correct, I will happily give you the points. And finally, we've got 1D. So what did we have for 1D? A javelin throw. So you've got body transport, object manipulation, very good. No intertrial variability. There might be that nothing in the environment affects it in a way that every single time you throw the javelin, it's going to be different. Yeah, that's fine. I can deal with that. And regulatory conditions are stationary. If that would be in practice, right? We're not playing against someone else, etc., then I would argue that that is correct as well. Does that work for everyone? Do you kind of understand where we're going? Yeah. All right. Excellent. So, Gentile's taxonomy, that two-dimensional taxonomy, is useful because, one, it can help us understand how difficult is a motor skill actually for a person. The second thing is it helps us to understand capabilities and limitations. Maybe someone could perform a 1B, but not a 1C, or not a 2B, and we understand what their capabilities, what their limitations are. It also allows us, and this is where I could place the most emphasis, also in your questions in your exam, it allows us to understand how to build progressions for individuals. If someone is capable of doing 1B, and we slowly want to progress them all the way to 4D, then you now understand which types of things you have to add to exercises or motor skills that are already doing to slowly progress them in that direction. And obviously, it allows you to chart the learner's progress. So, as I said before, Gentile's two-dimensional taxonomy is really useful because it allows us to build progressions and regressions based on the fact that if you move more to the right in the taxonomy table or more downwards, there should be an increasing demand on the motor control system for someone performing those skills. Right? And that's where Gentile's two-dimensional taxonomy really becomes useful. A regression is usually an exercise that places less demands on a motor control system. Right? If someone's relearning how to walk, then we might have them stand in a room first, right? If someone just received a new prosthesis and they're supposed to learn how to walk with it, then it might be really useful to first let them get used to not having perceptual flow, right? And eventually we can progress them to doing more complicated exercises. That might mean they might be using object manipulation while they have their prosthesis on, right? We can also use progressions, as I mentioned. Gradually, we can increase the demands on the motor control system by moving to the right and down in Gentile's taxonomy. If someone wants to learn how to swing a bat, hit a ball in actual baseball, can someone give me an idea of what a regression would be based on Gentile's two-dimensional taxonomy? Using a T because what are you taking away? So compared to baseball, which in this case would be 4D, all the way to the bottom and to the right. What are you taking away in Gentile's two-dimensional taxonomy? If you place the ball on a tee. Intertrial variability and yep, regulatory conditions in motion are taken away as well. Right? Very good. How about a regression, a progression of this exercise? Let's say we are at 4D because there's some sort of body transport, someone stepping into the ball. If we are at 4D, how do you build progressions after that? Sorry? Make the ball smaller, throw the ball faster, get specific tactical goals, etc. And that immediately pinpoints the limitation of Gentile's two-dimensional taxonomy. Even within every single cell, there are a multitude of progressions that you can still use. When I'm asking you on your exam, I'm asking you to find a progression and a regression. Don't find a progression and a regression within the same cell, because then I wouldn't have asked you in the first place. Right? I want you to use Gentile's two-dimensional taxonomy to find progressions and regressions. All right, so what have we done in this part of the lecture? Well, we've looked at two classification systems for motor skills. One-dimensional and two-dimensional systems. The two-dimensional system, we already said, is useful for these things. In summary, or in conclusion, there is a way for us to understand what the demands are that are placed on a motor control system by motor skills by using this simple taxonomy table. In the end, that's a tool every single practitioner can use, and I'm in the practice or in the field in practice quite a lot nowadays, and this is something that is not well understood, not even by the most senior of coaches. Oftentimes they do not understand that a skill can be classified based on how difficult it is for a person to execute based on just these simple taxonomies. Yeah? Any questions about this part before we move on? No? All right, excellent. So, we'll give a short introduction in how to measure motor performance. Of course, this is a massive field. Right? You can study your whole lifetime and not understand this field. We'll quickly touch on a few commonly used concepts or commonly used measures of motor skill performance. Why that becomes interesting is because ultimately, at the end, in week 12, you'll have a laboratory session, and in that laboratory session, you will come in. I will give you a cup stacking set. Everyone knows what cup stacking is, right? Everyone's seen the videos. Don't start practicing it yet, right? I'll give you a cup stacking set, and you will design an experiment in which you try to accelerate cup stacking acquisition, so learning on the cup stacking skill in that 2-hour laboratory. Right? As a part of that, you'll have to measure, or you'll have to have some sort of measure of motor performance. Otherwise, you don't know whether you've improved or not. Right? So that's something to look forward to in week 12. But I'm just telling you, it's really important to try and understand how motor skills are measured. And we can already understand that that's quite complex. In a field as wide as ours, how do you have one measure that might say how well someone performs a dance routine versus how well a child grasps a block? Right? How would we measure performance here in the dance routine? No dancers. If I had more time, I'd do a routine and you could score it, and I'd try to do it twice, but unfortunately. Fluidity of movement? Yeah, fluidity of movement. And do you know in which way we might measure fluidity of movement? What would you do just purely instinctively? If you had to measure whether these people were good at dancing, what would you do today? Come on, creative souls. The youth of today. How many errors they make? Great. So you could use an error measurement and you could look at, all right, this is the dance routine they're supposed to execute. This is what they're executing right now. How many errors do they make? And what is the magnitude of those errors? Very good. What about the baby grasping the blocks? Very good. How many attempts? So they might try and grasp a block and pull back, grasp a block, pull back, and only one time out of 10 they might actually move forward and actually use the right aperture of the hand to hold on to the block. Very good. You're not motor control specialists yet, right? But you have some sort of understanding of how we generally measure motor skills, and it's quite good, right? There's different types of measures that we can use. We can use what's called a performance outcome measure. It tells us something about how did we perform specifically, right? What was the outcome like? How fast were you over this 100 meters? A performance outcome measure. However, with performance outcome measures, the issue is we have no idea how someone achieved that outcome, right? And for an expert, it's fine to know, all right, I ran 9.78 today, 9.76 tomorrow. All right, I did a little bit more of that. I think this is why I'm performing better. For an expert, that's fine. When we're working with novices, we really have to understand what is the reason why they produced a particular performance outcome. And that's what's called a performance production measure. Right? For example, your legs were lifted 90 degrees is an example of a performance production measure. Commonly used performance measures that you would have all seen before. Reaction time. Right? Everyone's heard of reaction time? Yeah. Error measures, we just discussed that there, and then kinematic measures. And we'll quickly discuss each one. Reaction time is an interesting one, because when you say reaction time, I'm fairly certain that what you actually mean is response time. These definitions are often difficult. What reaction time is, and this is a diagram, I say it every single year, and every year people get it wrong in an exam, right? This diagram is in your exam, the bottom one, the one with the red and the blue. And everyone sees it, writes it down, writes down with a note, this is an exam question. At least 1 out of 100 points in, yeah? Reaction time is the time between a stimulus and the visible force, right? Or the visible movement. What that means is if someone is in a 100-meter sprint race and they're ready at the 0 point, right? There's the stimulus, the sound of the gun, until there is an explosion of force on the blocks. That is what's called the reaction time. After reaction time, we've got the interval between the explosion of force against the blocks and actual visible performed movement, and that's called movement time. And so actually, oftentimes we talk about reaction time, right? Oh, that player's reaction time is great. Did you see his reaction time? What we really mean is movement time, because we mean from stimulus to the end of the response, right? But why is measuring reaction time so important in motor control? Why do you think that as a measure, a primary measure in many experiments, we would use the concept reaction time? What does reaction time tell us? If you've got a faster reaction time than me, what does that tell you? Yeah, it says something about the efficiency of the nervous system, right? Who has a faster reaction time than their grandma? Yeah, of course, right? It tells us something about how efficiently our central nervous system is performing. Do you all have a faster reaction time than me? I don't know your names, you can say whatever you want. Yes or no? Yes, of course. Why? Because it doesn't matter how old I am, but I'm older than you, and we know that cognitive decline, which means, right, the time at which that connection between the central nervous system and the muscle, cognitive decline, starts at what age? All right, let's raise hands. Who's 21? 22? 23? 24? 24 or older? That's it. 24, that's when cognitive decline starts. After 24, your reaction time will probably never be the same as it was before. Right? Unfortunately for us, that's just what it is. Right? However, I'm talking to you now. Who are the best drivers here? Us or them? Of course. Why are we better drivers knowing that reaction time is so important for driving? That's right. It is not just when we measure reaction time, right? In experiments, we're measuring how the central nervous system works outside of the influence of everything in the environment. When we are sitting in the car, right, our reaction time is determined by how well we can read that environment. And I don't mean to say I'm a better driver than any of you. I'm sure that's not always the case. But in many cases, we do see that older drivers, even though they have cognitive decline, are still really good at driving a car. And so that's the difference between reaction time and sort of using the environment to anticipate, right? So measuring reaction time permits us to study a system that works efficiently. It allows us to understand the underlying mental processes, and we can look at how variables affect reaction time. And we already said that reaction time can be influenced by how many choices you have to make, right? This is one choice, easy to avoid. Many choices, very difficult to avoid. And usually, you react a lot slower with the more choices that are available. Same here. Red or green, easy, quick response. Red, green, yellow, maybe an arrow, maybe not yellow, maybe another sign next to it, slow response. The more information you have to process, the slower your response becomes. The older you get, the slower your response becomes. Something we already said, that cognitive decline starts at 24. And then lastly, the last thing I want to mention is what's called error measures. Error measures tell us something about what the deviation is of a previously set standard in our performance, right? You can be accurate or have the same accuracy, goal for A or goal for B, but very different performances. Goal for A was very inconsistent, goal for B was very consistent. And we do that by calculating three types of error: constant error, variable error, and absolute error. Constant error refers to the unsigned deviation from a target. Variable error relates to the consistency, and absolute error is a signed deviation from a target. Lots of words, difficult to understand. I'll give you an example. All right? And I'll give my own example. I like that more. If you calculate my constant error is the signed deviation from the target. That means I'm taking into account the minuses and the pluses. Over all my performances here, I did it 13 times. If you calculate all of that, right? Even though I haven't hit the target even once, I'm exactly in the red target. Belgium on #1, goal for world champion. I haven't scored a single one, right? But if I calculate my constant error, which would be -30 plus 2 times -15 plus 9 times plus 5 plus 1 time plus 15, etc. Everyone understands the difference between signed and unsigned? Yes, so taking into account the minus and the plus in a constant error, not doing that in an absolute error. Alright, so my constant error, I'm the best golfer in the world. But when I calculate an absolute error, I have an average deviation of 9.2 centimeters. Alright, so I'm somewhere there. Or there. Because calculating an absolute error, I do 30 plus 2 times 15 plus 9 times 5 plus 1 times 15. Yep, so I don't take into account the fact that some of my attempts were short and others were long. Right? That's absolute error. And finally, variable error relates to the consistency. Someone who has very low variable error is someone in the top left and the top right there. Very consistent performance. Maybe it's not accurate, but it's super consistent. However, the bottom two, they have a large variable errors. They are inconsistent. Right? Then, finally, we've also got, when we talk about motor control measures or measures of motor performance, we've also got kinematic measures. You know all of these from biomechanics, and I hardly ever ask you about them, but you know that there's displacement, velocity, acceleration, a linear and angular motion. That's interesting because it tells us something about how someone produces a particular outcome, right? If I was a very consistent golfer, then we might use that information to say how I become so consistent. And maybe my movements are exactly the same every single time. You've also seen diagrams like that. And then finally, we've got EMG. Right? We can also use muscle activation to tell if someone is controlling a skill really well. Because what you ultimately want is you want the most efficient motor control system possible. You want to expend the least amount of energy to get the best possible outcome. So we can measure how much muscle activation someone has, or what the timing of that muscle activation is, or how much musculature someone is engaging. That is not relevant to the performance of a motor skill, and that also tells us something about how someone performs. All right, so we've used classification systems. We've briefly touched on measuring motor performance. Not really that important yet because a lot of these measures come back, but it's important that you know that even though we can classify skills, we still have to have a much more refined method to tell us something really about how much or what the demands are that a motor control or a motor skill places on a motor control system. All right, that's it. Thank you very much. If you have any questions, come forward. If not, I'll see you next week.